Hello, guys. Very welcome to all of you. I hope everybody is fine. And in continuation to our interaction, in continuation to our videos, let's talk about the foundation of two worlds. If you look at your hands are warm, they are soft, they are alive. Now remember this. Remember this carefully. Look at your hands. Okay, they are warm. They are soft, and certainly every atom inside your hand obeys the same laws as the atoms inside a rock, as the atoms in a star, or a cloud of gas that's drifting between the two galaxies. They are obeying the same set of laws. There is no special exemption for life. If you see, if you observe, if you analyze the whole range of existence. And yet, life does something no rock ever does. I mean, the biological life. It does something that you cannot expect from a rock. And it maintains order. It resists, it fights against the decay, even though decay is going on and on, but it persists, it goes against it. It persists against the chaos. It struggles against the chaos. So friends, today we are trying to learn and we are trying to ask a very fundamental question, a very profound question. And the question is that how does living matter obey the laws of physics and still remain alive? I mean, they remain alive in a biological sense, in a biological tone, in a biological mechanism. So, living matter, you cannot assume it as a kind of magic. It's not a magical thing going on. And at the same time, it's not doing anything outside the laws of physics. It's not doing anything outside the laws of science. It's not basically a violation. It's not the violation of the thermodynamics. It's not the violation of the laws of thermodynamics. Living matter is organized matter. It's a matter in the form of aperiodic crystal, as described by as described by Erwin Schrödinger. And there is this continuous flow of energy. This single sentence, this single argument will guide us. It will make us learn everything. It will make us learn to an extent we can learn about it. And for that, let's take an argument. If I tell you, imagine a candle burning in a dark room. And this candle has a flame. The flame has shape. It has a geometry. And the flame has structure. The candle is burning. It has a flame, it has a structure, it has a shape, it has geometry. And this flame has a motion. But the flame is not a thing. It's not something like an object. It's a process. It's a process going on. The moment the fuel for this candle stops, the moment fuel stops flowing, the flame disappears. And life is closer to a flame than to a stone, than to a rock, than to a chair, than to an object. So flame of the candle is close to the biological life. Now, from the standpoint of physics, from the physics point of view, every living system is an open system. Every living system is an open system. And what happens basically is energy enters into that system and energy leaves from that system. So what happens here is matter. When we say matter, matter flows. So when matter flows, information is processed. This information is processed. Now, if this flow of energy, if this flow of matter stops, the system relaxes. The system relaxes into equilibrium. And we can say that life vanishes, life destroys, life comes to an end. This idea is formalized by the second law of thermodynamics. The idea that I was trying to set on the argument is based on the second law of thermodynamics. So what it says that the total entropy of the universe always increases. As entropy, we understand the disorder. The magnitude of disorder of this cosmos increases. And yet, here is the apparent paradox. We have an apparent paradox. What's that? Living systems, living biological systems, what they do basically is they locally reduce this disorder. They locally reduce thermodynamics. And what they do, they build structures. They build the biological buildings, the biological structures. They create order. They create order, and at the same point of time, they maintain complexity. Because life has complexity in it. But at the same point of time, it's maintaining that order. It's going against the actual law of universe. This is not a violation, basically. It's a kind of trade. It's a kind of business that's going on. Now, to realize it in more general sense, imagine a city. Let's assume a city, Srinagar city at night. What's happening in this city is generally lights glow. And there is motion of the traffic. Traffic moves. And you have these big structures, the buildings, these tall buildings, they glitter, the light comes out of them. But none of this happens for free. It's not happening. It's not happening freely. Energy must be continuously imported. Or I can say the energy should be continuously imparted to these systems. And what's that energy coming from? That energy is coming from electricity. That energy is coming from fuel. And in us, in animals, that energy is coming from food. Waste must be exported. And this waste is exported in the form of heat. It's exported in the form of pollution. It's exported in the form of disorder. It's exported in the form of entropy. The city maintains order by exporting disorder. Now, living matter, living biological matter works in the same way, works on the same principles, works on the same actions. Same shots. Now, let's go a little bit deeper in this argument. Now, let's talk about the energy again. Now, what happens? Energy flows. Energy flows alone is not enough. A waterfall has energy flow. Yet, it's not alive. A hurricane, it has a structure, it has a motion, it has a rotational motion, and at the same time, it does not replicate the life. It does not replicate the biological life. So what distinguishes living matter? What distinguishes the living matter is the controlled energy usage at the molecular scales, at the atomic scales, at the cellular scales. And what happens when we talk about the molecular scales? At the molecular scales are ruled, they are governed, they are dictated by the laws of quantum mechanics. And this is what we are trying to understand. This is what we are trying to learn. So we can say the stability of molecules in living organisms, in the living beings, the stability arises from quantized electronic states. These electronic states are governed by Schrödinger's equation. The very foundation of theoretical physics, the very foundation of theoretical quantum mechanics, the very foundation of the quantum world. And what this equation tells us, this equation determines which molecular structures are allowed by the laws of quantum mechanics. And at the same time, which structures are not allowed, which bonds between the atoms can form, and which bonds cannot form, which reactions are possible. And without quantization, without realizing this stair kind of energy, without the quantization of energy levels, molecules would either collapse or they will fly apart. So you will have no stable microscopic world. You will have no stability in chemistry. You will not have the complex structures, no complex structures. So if there are no complex structures, there is no living matter. There is no biological living matter. That is what we are trying to understand. That's what we are trying to realize. And that's what we're trying to build our understanding on. Now, let me take another example. If you imagine a vast ballroom, and this ballroom is filled with dancers. Let us assume that there are dancers, they are dancing in this room. Now, the classical physics allows dancers to move anywhere in the room. They can go anywhere, and they can go anywhere with any energy that they have. But if you think about the same room, if you think about these dancers in the framework of quantum physics, so quantum physics restricts them to some specific floors. It restricts them to some specific rhythms. It restricts them to some specific steps they'll be using while dancing. Now, those restrictions, what they do basically, they make the patterns possible. You have those filmy patterns, and these patterns are possible when your actions are restricted. And this is what quantum does. And life dances because the floor exists. There's an existence of this floor. Let me take you to another example. Let's try to understand the same argument. Say, talking about the living matter. Living matter exists in warm, it exists in noisy environments. And warm, when we say warm, there has to have the thermal motion, and thermal motion constantly shakes the molecules apart from each other. So why don't biological structures dissolve? Why don't they break? Why don't they dissolve instantaneously, instantly? The answer lies in the energy landscapes. You have thermal energy, and molecules do not dissociate. So we have an equation of energy landscapes. The reactions are governed. They are governed. They are governed to go on. And they are governed by what we call as the activation energy. It's not like that they can dance anywhere. And what quantum mechanics does here, quantum mechanics allows particles to sometimes cross barriers. They can cross barriers by not actually climbing over those barriers, but they can tunnel these barriers. And this tunneling is what we call as quantum mechanical tunneling. This subtle effect that I talked about, the quantum mechanical tunneling, it basically dramatically accelerates the essential reactions in the biological systems. So certainly quantum has to do everything with the biological systems. Now let's first understand this quantum mechanical tunneling. Now if you imagine a mountain, okay, you have a mountain separating two valleys. You have a valley one, you have valley two. In between these two valleys, there is a very big mountain. Now, if you think classically, if you do classically, you must actually climb over this mountain and cross its peak and go into another valley by crossing the mountain. But quantum mechanics can allow a shortcut between valley 1 and valley 2 and a mountain which you are not able to cross, a hidden tunnel. A hidden tunnel through the mountain. And your particle booms from valley 1 to valley 2. Even if the energy of this particle is less, living chemistry survives because these tunnels exist. Otherwise, they won't. It's because of the tunnels that are allowing these reactions which are not possible classically. And now certainly comes something extraordinary, something we would like to understand, something we would like to learn. Living matter does not merely store energy. It's not like the biological living matter stores energy. What it does basically, it stores the instructions through the energy. It stores information in living systems. So we can say that information in living systems is physical. It is encoded in molecular configurations, the information, and it's constrained, it's obstructed. It's obstructed by the rules of quantum mechanics, by the laws of quantum physics. So, information is not abstract. What it does basically, it occupies space. It occupies space in us. It consumes energy. It takes order and it consumes this energy. And this principle was formalized by Landor. So what am I trying to tell? Erasing information, if you want to erase the information, it will cost you energy. And what life does basically, life pays this cost continuously. It does so continuously. It pays and pays as long as there is life. And there is an important argument of memory. And this memory is not only written in our brains, it's written in the matter. You imagine writing on sand near an ocean. You have an ocean, you write something on the sand. Now what waves does, the waves that come from the ocean, the waves constantly try to erase the message that you're writing on the shore, that you're writing on the coast, that you're writing on the border. Now, to preserve it, what you can do, you must rewrite it again and again and again. The waves are coming, they are taking it off, you're writing it again, again, and again. So living matter continuously rewrites itself. It rewrites itself against the noise, against the waves, against the distraction. So now if we think about stability and think about stability without stillness, and let's try to understand, let's try to have a critical insight in realizing this. Living systems are stable without being static. What am I trying to tell is the living things, they maintain identity. They maintain identity while constantly replacing the components. They keep on replacing the components, but they maintain the identity. So what happens to the atoms? The atoms come and the atoms go. And what happens to the molecules? Molecules turn over. They turn out their motions. So there is persistence in the structure. But the things are coming, going, coming, going, coming, going. This is dynamic stability. And it's a hallmark of living matter. It's a hallmark of biological life. It's a hallmark of us. Now, what could be the quantum mechanical perspective for this? What quantum mechanics does? It basically reinforces. What I'm trying to tell is, if we think about it at the deepest level, the thing that I'm talking about, what you have bonds between the atoms, and bonds form because of the very overlap of the wave function. The bond between the two atoms is a result of the overlap of the wave function of the two atoms. And reactions between the atoms proceed because there are certain probabilities that allow these reactions to happen, that allow these reactions to go on, that allow these reactions to act. And structures, they persist. They persist because they are allowed states. Their states are allowed. Their states are limited. Life does not fight quantum mechanics. It does not play the game of war with the quantum mechanics. It does not play the game of swords with the quantum mechanics. Life basically rides on the horse of quantum mechanics. So I'm trying to learn all of these aspects, and I hope we will try to learn what's going on. And if you remove quantum discreteness, as I was talking about, the chemical nature of that living reality collapses. You remove the energy flow, and the order that I was talking about, the order will dissolve. You remove information that we try to understand how it does, and structures lose the direction. There is chaos. There is randomness. Living matter exists. It exists at the narrow intersection. See, outside this framework, it's all disorder. It exists at an intersection of law, at an intersection of constraints. And this balance is not guaranteed. It is permitted. It's allowed. It is given a shot. It's given a permission. And if I imagine the universe as a very vast desert of equilibrium, as we try to understand what equilibrium does, in rare places on this equilibrium, energy flows carve temporary rivers. And along those rivers, matter organizes, matter makes order. What matter creates order. And along that organization, living systems appear in a sea of chaos, in a sea of randomness, in a sea of probabilities. Not forever, not everywhere on the desert, but long enough to ask a question about themselves. What is that question? What is that argument? We would like to talk about it in our next interaction. I hope we try to learn, but whatever we learn to learn why we are here.